Thank you. Thank you. Thanks for coming back. Good to have you all back here. You know it, we're talking about hydrogen manufacturing risk management. Hydrogen's been around for quite a while in the power generation industry. We've had it in hydrogen-cooled generators. In the oil and gas and chemical manufacturing industry, we've had it in hydrotreaters. We've had it in equipment that's used to basically control chemical processes that involve hydrogen. So we know a little bit about it, but now the country's getting into it in a big way. The world is getting into it in a big way. So we're going to talk about it. We're going to talk about the hazards and what we can do about them, and basically how to manage the hydrogen manufacturing risks. So let's jump into it. Here we go. We'll talk about NFPA 2. That's a nationally recognized standard. It's actually a code, so it has shall language in it. And we'll talk about Fire Department Liaisons, because NFPA 2 does talk about Fire Department Liaisons. In fact, it requires owners to establish Fire Department Liaisons. We'll talk about H2 Tools, or hydrogentools.org. Great website with lots of information. Pay for you by your tax dollars, but that doesn't hurt it. Then hydrogen fire scenarios. We're going to talk about what can really happen. So if we're going to manage risk and we're going to be risk engineers, what are the scenarios of interest? What can go wrong? That's what we're going to look at. We'll look at some actual real world incidents, what has gone wrong, and we'll actually take a quick side tour down the AI lane, and we'll have artificial intelligence help us summarize what's going on at H2 Tools as far as lessons learned. You're really going to like that part. And then, like I said, at the end, we'll get into a hydrogen risk engineering checklist for your risk engineering reports. All right, let's roll. Hydrogen, NFPA 2, some of the key features of NFPA 2. I'm not going to go all the way into the entire code and tell you what it says, but for just understanding what it's there for, it covers the generation of hydrogen, installation of your equipment that you're going to use in a hydrogen facility, how you'll store your hydrogen safely, rules on the piping and what the fittings and all the components are that you use to carry hydrogen, how you use hydrogen safely, and whether it's in a component in a machine or if it's in a process, getting it from where it's made to where you need it is important. So handling procedures are also covered in NFPA 2. NFPA 2 talks about fire department liaisons. Okay, fire department liaisons, it's a great idea. I worked in a company 20 years ago. We started this concept in the utility space, and we'll talk a little bit about how it applies in hydrogen manufacturing. But here it is. NFPA 2 says that you shall designate a liaison to the fire department. Okay, and they're going to be there to basically provide information on the hydrogen and coordinate the emergency response activities. Okay, it's very hazardous to bring people in from the outside of your plant maybe once a year, and then they come in during an emergency at night and expect them to just know where they're going. So we need someone to be with them. Okay, one of the things that the fire department liaison provides to the fire department is a description of the system. You know, these guys are working in their fire stations, and when they get called out, it's to a car fire, a house fire, a kitchen fire, a basement fire. You know, they really don't know what they're going to get to, even with a call when it goes out that there's a residential fire. They don't know if it's 1 or 10 or, just what's in the basement that's on fire. So it helps a lot if they know what they're going to have before they get there. So we'll give them a system description of the hydrogen plant. We'll give them a site plan showing them where everything is. We want them to know where to go. We want them to know where the hazardous equipment is. We want them to know where the expensive equipment is. We want them to know where the sensitive equipment is. We don't want them to just spray water on the control room if they don't have to, if there's a way they can approach that. If they knew that it was sensitive, they might approach it differently. So we want to have them with all the information necessary to respond to our emergency the best. All right, we have hazard analysis, and in this, what you'll do is you'll go through and basically lay it on the line, tell the fire department what can go wrong, what you expect in your facility as to, the things that if all your luck were bad, this is what would, be the worst case. These are the things that the fire department needs to be aware of so they don't have to be afraid of everything. If you narrow down what they're aware of as far as what they should be concerned with, that will help really focus them. Because I'll tell you the truth, we had a fire department escort program in a power plant a while ago, and a lieutenant from the fire department's in during a tour with us, and he says, "You guys make electricity, your floors are made out of metal, and you want us to come in here and spray water all over the place. That doesn't sound comfortable. So you see, when they're coming in, they have some preconceived ideas of what the risks are. So we have to make sure that they're aware of the right risks. Then the emergency response plan, this is going to, let them know that, yeah, we've got folks that'll be with you when you get here. They'll be dressed like you. They'll be able to go into the hot zone with you. They'll guide you. They'll make sure that you don't get lost. And that if you need any resources, you have a one-on-one contact that you can get something done when you're dealing with our emergency in our plant. And what else are we going to do? Our liaison is going to set up a training program for the fire department, because guess what? Their local academies, the fire department training that these folks get is not specific to hydrogen plants. So we're going to have to develop a program, and we may have to sit down with the instructors and ask if we can get some time in one of their modules, ask if they would like us to come in as a representative of the manufacturing facility to give a presentation to the instructors so that they can then train the recruits. And then finally, the fire department wants a schedule for all the inspections, the testing, and the maintenance of the equipment in the plant. They want to make sure that the facility is being maintained, because that's the one of the best ways to figure out if you're going to ever have a fire there is if they're not maintaining it. Now, I'm not going to read through this. I know it's pretty small font, it's blurry, but this was lifted out of the long document, 30-something page document that we generated back at the utility I worked for to control our fire department liaison, our emergency response liaison program. But it basically lays out the roles and responsibilities. I'm putting it up there so everybody can pause on it and come back and take a look at it. All right, now let's talk about what can happen in a hydrogen manufacturing plant. What are the fire scenarios? What are we worried about? Well, I had a little chat with AI and Bing, and some of the insight that I got was that we're looking at leaks and ignition. Okay, hydrogen's got it's a very small molecule, so it tends to leak very easily, and the typical equipment that holds a methane molecule in, like natural gas, the seals and the tightening procedures and the processes we use for natural gas don't quite work for hydrogen. So we have to be very careful about leaks, and we have to have leak detection systems and be aware of them and monitor if there's a leak before it ignites. And then accumulation and explosion. It's amazing. Hydrogen's very light and it travels upward very quickly. And as some of y'all know, I like to golf, and I used to work at a golf course back at the University of Maryland. And in our maintenance barn is where we would charge up the maintenance equipment. We had tractors and mowers and all that. And one day, Danny, one of our guys, he goes to the batteries in the tractor had been charging overnight, and when Danny went to put the cables back on, he put them on the wrong terminals and got a arc. And little did we know, a pocket of hydrogen over the years had been developing in the maintenance barn under the roof. It had nowhere to go. The roof was watertight, so it was hydrogen tight in this case, and we had a little puff that did damage the roof somewhat, and poor Danny had to get his shorts cleaned. So hydrogen can build up, and you don't know when it's building up, and you just have to be careful about the accumulation. So that's why we need detection in areas where we're not necessarily going to have ventilation. Jet fires. All right, my experience with a jet fire, and this is when you have a flange or a high pressure leak that then ignites. What I've seen is that the damage is very localized. The damage, unless you've got another combustible that's going to burn, catch on fire, and spread that fire, you're pretty much going to have a lot of damage in one small place. Just like if a welder fell asleep with his torch on, it's not going anywhere. Okay, so it's important because it's very hot. These torch fires can be extremely damaging to the local area, and if that causes other equipment to fail, then you've got a chain reaction you have to be careful of. The other thing that I see with these jet fires is you have to be careful. If you put them things out, but remember, the flame isn't even down along the metal. The flame is out away from the leak. So it may not take much to put that fire out, and then you have to deal with that cloud of gas. So be very careful about dealing with jet fires. And again, fire propagation boils down to where you store it, where you keep your combustibles, how your housekeeping is. So if we run a clean facility, we're going to have less chance for fire propagation. All right, let's go take a look at Hydrogen Tools. Where are you at? There you go. All right, Hydrogen Tools is a cool website. It is funded by the government, and we will take you through it. But what I found amazing here was I went up and just looked at the little resources tab, and I came down to lessons learned. And once you get over to lessons learned, you can see right here there's 221 results found, and you can categorize them and sort them and pick what kind of lessons and what kind of events you wanted to look at. And you can see each one's got sort of a clickable link that takes you to the full report or a little summary of what the lessons learned were. But for you AI geniuses out there, come along. We're going to click this little button up here that gives us access to Bing. Bing is a chat type bot that is part of, well, that can come along with Microsoft Edge. And you can see that all you really have to do once you click that button, this panel opens over here. And, I want more precise responses. And I simply could have said summarize this page or generate page summary, but instead I decided to write summarize this page. And I even spell it wrong. Doesn't matter. The AI figures it out, and it gives us what the items of interest were. These 4 points: rigorous procedures, material compatibility, safety interlocks, training and awareness. Okay, it gleaned that by reading all of this. It saved me from having to read all these reports and figure out what were the common themes to all these reports. Yay, AI. So what we will do now, we'll come back, and there's got to be a lot more to H2 tools. I haven't dug into it much more than lessons learned. I'm so fascinated with those. But let's keep going. Now, the hydrogen incidents that have occurred, they were, again, this was from the little research that I did, but basically, if we had good procedures and documented everything we did according to our procedures, we wouldn't have had these incidents. And I think that's just a case of all process-related risk, is that the best of intentions, right? We have good procedures, and it's difficult getting folks to follow them, adhere to them. Leak detection and ventilation could have stopped it if we had better leak detection, if it was maintained properly, if it was in service when it was necessary, if it was spaced right. You got to be careful with detection and ventilation, because if you have too much ventilation, you may not detect the gas, right? And if you don't have any detection, you won't know when to turn the ventilation on. So they have to work together, and it's a good option or opportunity for risk engineers to help. All right, material compatibility. We've had this problem in the process industries for quite a while, so it's just sort of bleeding over into the hydrogen industry, but making sure you have the right material that's going to be compatible with the products that you're flowing it. Like I mentioned earlier, the molecules of hydrogen are very small, so they're going to leak through tighter seals than methane or water might leak through. So we have to be careful about what the material compatibility is. Its reaction with the material is going to be different. We can cause embrittlement in carbon steel if we have hydrogen get into that steel structure, into that molecule structure. So the materials that we pick can be damaged by the hydrogen. We have to be very careful. There's a process called a positive material identification, a whole complete program in facilities with PSM, and process material identification, PMI. They even have PMI guns where you can put the PMI gun on your material, and it will use lasers and technology, and it will tell you what your material is. So, there's really no reason not to have a good understanding, especially in newer facilities that are being built now, exactly what you have. Now, just because it's new doesn't mean that the manufacturer's checking the material compatibility. I have had a heat recovery steam generator, brand new, fail within months of service because they used the wrong steel in it. Interlocks. Right? We want to make sure, like I mentioned earlier, that we have a way to turn on ventilation, say if we have detection. We want to have interlocks that will shut off a compressor, say if the suction temperature is too high, or if we're getting liquid in the suction line. So there's various interlocks and training that are used to prevent all of the incidents that the AI saw going on in the list of the h2tools.org. Alrighty. Training and supervision are essential for operations, and we'll talk a little bit about that when we get into the checklist. But These are the things that it's interesting that I see some very similar items that would be on a checklist were the reasons that led to the multiple incidents that we saw at H2 Tools. All right, so here it is, the long-awaited risk engineering report checklist for hydrogen manufacturing facilities. I did not create a form that you people are going to be able to just print out and go use, so you're going to need to take a little bit of time to think through it, but put down all of the information that you're going to want to capture in a good risk management report, risk engineering report for a hydrogen facility. And a lot of this is going to sound familiar to risk engineers. This is for the new risk engineers that are learning. So you're going to want all the general information about the facility, the contact people, who was there, who do you talk to. And remember, when you're writing this report, it's not just for you, it's for other people. It's for your underwriter, it's for the other engineers and underwriters that are interested in that risk. So write a good report that puts in a lot of detail. Some insurance companies restrict their engineers from providing too much detail in their reports, but when we're writing risk engineering reports, marketing reports, or anything that's going to go to the client to help them manage risk, it really needs to have all this information. It can't just be a report with this is a hydrogen plant and here's all your recommendations. Okay, those are what insurance companies can write, but risk engineers who really want to provide a value will provide a lot more information. The layout, we're going to have a detailed site plan, and in the plan we're going to tell them where the hazardous areas are. We're going to tell them where the resources are. Where's the water? Where's the foam? Where's the dry chemical? Where do they go to get resources on site? Where are the areas of refuge? Where are they going to pull the victims or potential victims from the facility? Where do they need to focus on when they get there? All right, hydrogen systems. We're going to go through what types of systems, the technology. We're going to talk about whether there's liquid, whether there's gas, if it's cryogenic liquid. We're going to talk about the capacities, the flow rates, basically all of the operating data about each of the systems. We'll talk about the safety measures. We'll have a whole section on fire protection, detection, suppression systems, leak detection, safety interlocks, ventilation. We're going to have a general section on all the safety. We want operating procedures. We will describe what the plant has for standard operating, normal, emergency, all with respect to items that could interfere or that could impact risk, right? And we're talking about risk to our equipment and our property. There will be a protection benefit of protecting the people, but the main focus of these inspections are going to be property inspections, and therefore we're not really going to make any kind of determination on whether it's safe for people or not. But we'll be there, and the fact that we're looking at things will make them be safer. Then we're going to look at incident history. We're going to see, has anything occurred? What did they learn? What have they done to prevent recurrence? And, this is basically the bottom line of, what you're going to have in an inspection report. And a lot of it's familiar to you. You've probably seen this in reports for chemical processes. But let's dig a little bit deeper. We're going to look at, do they comply with NFPA 2? So there will, you do want to point out if there's any large discrepancies between what their operations are and any of the current codes and standards. However, your review is not a code review, and anybody who reads your report should not think that because you didn't mention anything about NFPA 2 that they're in compliance with NFPA 2. Couldn't be further from the truth. Okay, we want to talk about any kind of pending or ongoing activities that they have, what their emergency response plan is. Does that involve fire department liaisons? How is it arranged? Is it 2 per shift? Is it 1 per shift? What's the staffing of those folks? And do they do drills with the local fire department? Are they going to the fire department and training, or are they having the fire department come to the plant and training? Is it a little mixture of both? And, it's important because when the fire department comes to your site, you kind of think they know what they're doing, and they kind of think you know what your plant hazards are. So everybody needs to be on the same page. That's what we have for hydrogen manufacturing risks, and hopefully got all of you to stick through it. And we're going to cover a little bit more in hydrogen as we go along. So keep watching, and